Hi everyone, my name is Olga Nahurna, and today I'd like to present a paper co-authored with Mariana Romanyshyn. The title is Gender Swapping as Data Augmentation Technique, Developing Gender Balanced Dataset for Ukrainian Language Processing. So let's start with why this topic is important. Ukrainian is one of the languages with grammatical gender, so ignoring the difference in grammar is actually a mistake. However, if you look at the table, the value in the second column of the feminine row might seem correct to you, but actually it is not. Unfortunately, feminine forms remain underrepresented in most existing datasets, ruining gender balance and introducing gender bias. And let me show you concrete evidence of that imbalance. Despite there isn't much research on measuring the actual ratio between feminine and masculine entities in Ukrainian text, there is one important study by Olena Sinchak and Vasil Starko called Feminine Personal Nouns in Ukrainian, which reveals how feminine job titles were used in Ukrainian language corpora over the last 2 decades. This chart shows that the frequency of feminatives is increasing, but usage is still sparse and inconsistent. That might cause a big problem for training language models because if our data is inconsistent or grammatically flawed, the model will reflect it. On another two charts, you'll notice a clear spike in the use of feminatives since 2019. The sharp growth represents the introduction of the new Ukrainian orthography in 2019, which officially recognized and standardized suffixes for creating feminine nouns, including job titles. So, analyzing all charts we presented, you can see that the use of feminine forms has started to increase, but there is still a lot of incorrect grammar. Therefore, gender balanced datasets with both masculine and feminine forms are essential for building fair and accurate NLP models. In the next section, I'd like to explain a couple of key terms. Unlike English, Ukrainian is what linguists called a morphologically rich language. This means it marks gender across many different parts of speech, not just nouns and pronouns. Consequently, gender swapping, the process of inverting the gender marked part of sentences, becomes more complex but also much more meaningful. On the table, you can see how sentences change after gender swapping in Ukrainian and other morphologically rich languages. But the term called gender bias isn't a problem. It isn't a problem only for morphologically rich languages. It is a widespread issue in many English NLP systems. For example, do you remember when Amazon had to abandon its AI hiring tool? It was discovered that the system was unfairly declined resumes containing the word women's. So this is a kind of situation happens when the training data itself reflect existing gender bias, and that's exactly what we want to avoid. So, what's the solution to this problem? Instead of trying to fix biased models after they trained, the counterfactual data augmentation let us teach the models from the start by providing example of both masculine and feminine forms. And to solve this issue, we built a methodology with a four-stage pipeline. Firstly, we selected a dataset with gendered entities. Next, we use a language model to swap gendered sentences, creating counterfactual versions. After that, human annotators carefully reviewed and fixed any mistakes in the generated sentences. And finally, we fine-tune a model using this newly created gender parallel dataset. For the original dataset, we used NER UK, the largest Ukrainian corpus annotated for the name entity recognition, consisting of news, media text, and broad format annotation labeled with text like person, job, org, and others. Our main focus was on job title entities as they are gender marked and suitable for swapping. So all sentences used for further gender swapping have job entities. After having data, let's move to the actual gender swapping. The gender swapping was done using GPT-4o Mini, chosen for its balance of accuracy and efficiency, and guided by a carefully crafted prompt to reduce grammatical and lexical errors. It is important to know that we focused on job titles and related words for correct agreement. Not every gender-marked word need to be swapped. Since outputs weren't always perfect, as shown in the example, we used a human in the loop process. For this, we involved 17 volunteers, each provided with detailed instruction on how to review and edit the gender swapped sentences, and together they worked through around 1500 sentences, carefully checking and correcting them when needed. On this slide, we can see an example of the annotator's work. They identify the error in the gender swap sentences and then carefully fix it. The results we obtained were somewhat mixed. More than a third of the sentences were incorrectly gender swapped, which shows that LLMs still struggle with gender transformation in Ukrainian. However, there is a clear improvement after human correction because around 83% of the job entity pairs matched entries in the gender pairs dictionary. After filtering and gender swapping, we obtained around 1400 silver quality gender parallel sentence pairs. Okay, now that we collected our gender swap dataset, let's move on to the experiments we conducted. In the first experiment, we created the gender swapping for the Ukrainian language via LLM. Firstly, we collected the gender swap sentence pairs I mentioned before. Next, we made sure to balance the dataset with an equal distribution of male to female and female to male sentence pairs. To enrich the data, we incorporated additional gender terms from the gender pairs dictionary. Then we split the dataset into training and testing sets using an 80-20 ratio. Finally, this process resulted in a clean, balanced gender parallel dataset ready for the model training and evaluation. For the training, as our base model, we selected AYA 101, a multilingual instruction-tuned model supporting 101 languages, including Ukrainian. We fine-tuned AYA on our gender parallel dataset with two prompts at the bottom of the slide. First for the sentences and second for the word-only pairs. And let's move to the evaluation. Looking at the semantic similarity metrics like Blue, Rogel, and Bear score, all models perform similarly, indicating good meaning preservation in gender swap text. But let's look at the match metrics. We see that fine-tuned AYA and GPT-4o Mini both outperform the original AYA overall. However, the job match metric stands out and shows that both AYA models perform far better compared to GPT. This suggests that while LLMs like GPT keep the structure well, they still struggle with generated correct feminine forms. Overall, these results show that fine-tuning with gender-balanced data helps model improve in gender swapping tasks. Now let's move to the experiment number 2. To evaluate NLP tools' performance on gender-marked entities, we train a NER model on a gender-balanced dataset by augmenting each original NER UK sentence with its gender-swapped version. Such approach allowed us to perform data augmentation at the sentence level and create a gender-balanced dataset. As a result, the augmented dataset has a much more balanced gender distribution compared to the original data. Looking at the tables, you can notice that for job entities, this shift plays a crucial role in achieving gender balance, and for pairs entities, the difference is less noticeable, but the distribution becomes close to equal. As a baseline, we use a state-of-the-art Ukrainian NER model from the NER UK paper. To ensure a fair comparison, we follow the same training configuration and pipeline from the original study. This includes training a classifier based on the Ukrainian Roberta large model, implemented using the SPACY framework. After running evaluation on the 3 different test sets, we got the next results. Focusing on the job class, the gender balanced NER model shows improved performance on the gender swap test set, slight gains on the augmented set, but a decline on the original set. Pairs performance stayed stable, likely due to balanced gender representation. Then, to understand job results, we split entities by gender and measure recall. The model improved on feminine entities, stayed consistent on common gender titles, but dropped on masculine ones. This shift may be due to the changes in gender distribution, larger training data, and the original model's bias toward masculine and feminine entities. And now let's summarize the key takeaways from the work. Here are the main contributions we made. We created a dataset of parallel sentence with original and gender swap pairs. We developed a gender swapper for Ukrainian using LLM, built a gender swapped NAIR dataset to improve name entity recognition, and all source code can be found on the GitHub repo, and both NAIR and fine-tuned AI models located on Hugging Face. And here's the future work and the main limitations. First, we'd like to extend gender swapping from the sentence level to entire documents for handling the context and avoiding duplication. Also, to replace GPT-4o Mini for the initial gender swapping with an open model to make the process more reproducible. Additionally, we notice a bias with LLM generated names. And finally, we want to expand beyond job titles to other gendered entities. And I guess that brings me to the end. So thank you so much.